learnt in your previous classes that the sour and bitter tastes of food are due to acids and bases respectively present in them, right? Also, if someone in the family is suffering from a problem of acidity, which of the following would you suggest as a remedy? Lemon juice, vinegar or baking soda solution? Of course, it's going to be baking soda solution because it is a base and it will neutralize the acid and relieve us from pain. So, to know how this exactly works, you need to know what an acid is and what a base is. Acids are substances which are sour in taste, that turn blue litmus red, and they dissolve in water to release H plus or H3O plus ions. Examples of acids include sulfuric acid, nitric acid, acetic acid, etc. Acids are divided into two types on the basis of their occurrence. They are divided into natural and mineral acids. Natural acids, as the name suggests, they are obtained from natural sources and that's why they are called as natural or organic acids. Examples are methanoic acid, acetic acid, oxalic acid, etc. Now let's see some of the natural sources in which these acids are present. You take vinegar, which is used for cooking. It consists of acetic acid in it. Ascorbic acid is there in guava and amla fruits. Citric acid is present in most of the citrus fruits such as lemon and oranges. Lactic acid is there in sour milk and curd, whereas methanoic acid is present in an ant sting and in a nettle sting. Oxalic acid is there in tomatoes, whereas tamarind consists of tartaric acid. Now coming to the second type of acids, which are mineral acids. These are acids prepared from minerals. They are also called as synthetic acids. Examples are hydrochloric acid, sulfuric acid, nitric acid and a lot more. Now let's see some of the chemical properties of acids, which includes chemical reactions of acids with various substances. And the first one is the chemical reaction of an acid with metals. When a metal reacts with an acid, you get two products, salt plus hydrogen. And the salt depends on what kind of an acid and what kind of a metal you choose. For example, if you're taking zinc metal and reacting it with HCl, you're going to get a salt which is zinc chloride plus hydrogen gas will be evolved. Now, how do you confirm that the gas evolved is hydrogen? There's a very simple test for that. You just need to bring a burning matchstick to the tip of the test tube wherein hydrogen gas is evolved. And if the matchstick burns with a pop sound, then you can confirm that the gas evolved is hydrogen gas because this is a characteristic test for hydrogen gas. Now coming to the second type of reaction, which is the reaction of acids with metal carbonates. A metal carbonate reacts with an acid to form three products, salt plus carbon dioxide plus water. For example, if you react sodium carbonate with HCl, you're going to get sodium chloride, which is the salt, plus you will get carbon dioxide and water. Now coming to the third reaction, which is the reaction of acids with metal hydrogen carbonates. Metal hydrogen carbonates are also called as bicarbonates. So upon reaction with bicarbonates, once again you're going to get three products, salt, carbon dioxide and water. And the salt depends on what kind of a metal hydrogen carbonate you choose and what kind of an acid you choose. If you're choosing sodium hydrogen carbonate and H2SO4, then the salt that is going to be produced here is sodium hydrogen sulfate, which is a combination of sodium hydrogen carbonate and H2SO4. Plus you get carbon dioxide and water as byproducts. Now in the above two reactions, it was carbon dioxide that was released. And how can you confirm that the gas evolved is carbon dioxide and not hydrogen? There's again another simple test for that. You just need to pass the gas that has been evolved into lime water. Lime water is chemically calcium hydroxide. And in such a case, if carbon dioxide is evolved, you can see a clear color change from colorless to milky white. This is because of the formation of calcium carbonate, which is a white precipitate. So this reaction will happen only if the gas is carbon dioxide, and this is a characteristic test for carbon dioxide. Now coming to the fourth reaction, which is the reaction of acids with metallic oxides. Metallic oxides are basic in nature. For example, you take copper oxide, which is a metallic oxide, which when dissolved in water gives rise to copper hydroxide. Now since a hydroxide is formed, you can say that this metallic oxide is basic in nature. Now what will happen if you react an acid with a basic metallic oxide? They're going to neutralize each other, giving rise to salt and water. For example, you react copper oxide with HCl, you're going to get copper chloride, which is a salt, plus water. Now you saw so many acids. What is it that you saw in common in all these acids? It's the H plus ions. Yes, acids when dissolved in water releases H plus or H3O plus ions, and that is common in all the acids. And it is this H plus ions that cause the acidic nature of acids. Now based on how much H plus ions are released, acids can further be classified into strong and weak acids. What are strong acids? An acid which is completely ionized in water to produce maximum H plus ions are called as strong acids. Examples include HCl, sulfuric acid, nitric acid, etc. Whereas acids such as acetic acid and carbonic acid are dissociated only partially and produce only a little amount of H plus ions. So such acids are called as weak acids. Now to summarize, acids, we saw the physical properties of acids, which includes sour taste, they turn blue litmus red, they conduct electricity in solution, and they release H plus or H3O plus ions in aqueous solution. And the chemical reactions of acids include reactions of acids with metals, with metal carbonates, with bicarbonates, and also with metallic oxides. And what was common in all acids? The release of H plus or H3O plus ions. And acids can be classified into two types based on occurrence as natural and mineral acids, whereas based on strength they can be classified into strong and weak acids.